need to use the notation of vector here because we have a force. So what is the variable of these two pair of the particle? So Vij is just, remember, Qi Fi. Just open at that. So Ri dot Fij plus Rj dot Fji. Now we just consider this quantity as a variable. If some minutes before I consider the minus for that, no. This is we consider that. We consider that sigma I Qi. Qi F. Because it is again, anybody is feel free to say what's the variable form. So I think this is the best. Don't think the word minus. Minus. So we need to make it this simplified. To make it this simplified, so Ri dot what? The force which the particle I feel, and Rj, the force which the particle j. So this is the force set to particle I from particle j. Particle j. And the same for here. Fij is the force from particle I to the j. Now you need to be very careful to writing the index. QIRI, Fi, what is the Fi? The force on the particle number I. So the force for the particle number I comes from the particle j, not from the self particle. We don't think about the self interaction, but this exists, but we don't talk about that. Okay, let's to make it more simplified. What information you have about the force? Fij, what we write Fij is actually, I told you, if this is a force from the particle I to j. From classical mechanics, you know that if the system has some type of the potential, so F can be written in the terms of the gradient. What is the condition to use this equation? Conservative. The system should be conservative, and the work done on the system should be independent from the past, and the work should be just given as the function of the initial and final position of the system. So can I write that here? So I will write gradient ij, which I don't know what is that, just I write gradient ij Fij. And this is that. And one thing is that Fij is minus Fi. Fji is minus Fij. So immediately using this information, the variable between a pair of the particle will be minus Ri, minus Ri dot Fij plus Rj dot Fij. Just I write Fji minus Fij. And make it collecting, so Rj minus Ri dot Fij. And instead of the Fij, I write minus gradient ij uj rij. Yes. Just nothing new here. Can I write this minus inside that? So I can write this Ri minus Rj dot gradient uj R Rj. You don't need it. There is a one-line calculation to want to show that the gradient of the u as a function of Rij is just gradient of the u if you consider derivative with respect to r. Anyway, I think you will clearly see that if the interaction is centrifugal or central interaction, if you have a central interaction, the r and the force are in the same direction. All this, anyway. Can I write this r just this and forget about everything? Potential will change just by distance, and this is the distance. So you do not need it to. But you know, the assumption here is that, I told you, the assumption is that the interaction should be just function of the distance. So you can write the variable r partial derivative of the r with respect to u. No, there is a one thing here. This is a Rij, yes? What is the Rij? Rj minus Ri, yes? But you have here, you have Ri minus Rj, so minus everything. So the variable will be minus r potential, the gradient of the potential with respect to r. So what we get is that Vij is just minus r partial derivative. What is the r? R is the distance between Rj minus r. And no angle, no angle entered here. I mean, this is the, see the picture, this is the Ri and this is the Rj. So they have angle also, yeah? Alpha. But in the variable, only the distance between them appears. So this is the r. Huh? This is r. From here to here, we call it this r. No angle. This is thanks to the interaction, thanks to the central interaction. I mean, if you relax this equation, so everything will be destroyed. We consider the interaction, or F, as a conservative force. Not all are like that. I told you, the spin interaction, for example, is not a conservative force. So the strategy completely will be different. Only for electrostatic interaction and something like that. This is the variable for the two particles. Huh? How many of these two particles you have if the number of the total number is n? So if n is sigmoid, ni is the, we don't get to compute. N is the total number of the number of particles in system, and you just did calculation for two. There is another particle here. It will work with that and that.